Alright, so today we're going to look at Quiz 8 from the second semester of Organic Chemistry from the spring semester. You'll have to excuse me, I'm still fighting a cold here, but I wanted to get this up for you guys before the final exam comes around. But let's take a look at problem 1 here and see what we can figure out. So, starting at the top, we've got a benzyl bromide plus potassium cyanide. So we've got a benzyl halide leaving group, right? And whoops, wrong size there. We've got a benzyl halide leaving group, and we've got a nice, relatively soft nucleophile that's coming in. And so all we're going to do here in this first step is just do a simple substitution reaction. You say, okay, I got that. Now, watch out here. The key to this is making sure you don't lose a carbon, right? So you're bringing in an extra carbon from the cyano group, and don't forget you already have that. You already have the benzyl carbon right there, right? So we got that green carbon that we brought in, and then we're bringing in another one from the cyano group there. And excuse me for just a second. I got to pause for just a minute. All right. Sorry about that. But anyway, so make sure you're counting your carbons on here. The next reaction then is we have that dibol H. We have it at cold, and we finish with an acid workup. Remember, dibol H is going to be a pretty strong reducing agent, but it's a controllable reducing agent at low temperature. And with a cyano group, we can take and make a aldehyde out of it. So we can turn our cyano group into an aldehyde, and that's a pretty powerful way of adding a carbon by using a cyano group there and then turning it into that cyano group into an aldehyde. Excellent. So next, we've got a ketone, and we've got an excess of a Grignard. This is kind of standard procedure here, right? With an excess, right? Let's change colors, right? Right, with an excess. Whoops, I got a little bit too excited there. Sorry about that. With an excess of the Grignard reagent, all we're going to do is, we're going to turn a ketone into an alcohol, but we're only going to add one of them, so it doesn't really matter how much we have in there, right? We're only going to add one of those into there. So there it is. Not too bad. Next, we talked about this quite a bit in class. This is one of these very important transformations, right? It's a Vidiq setup. So with a Vidiq, we basically add this group right here in place of that ketone or aldehyde oxygen right there. So in this case, right, we just literally swap that oxygen for that CH2 group there, right? And we looked at the mechanism. It's a useful mechanism to kind of know, but very important to recognize that there. Okay, lastly, one of my favorite reactions, right? We got an aldehyde or a ketone. We got an amine. So we're going to do a shift base reaction here, which means we're just going to take one of these nitrogens and just put it in place of that oxygen right there, right? And we're going to bring whatever else is attached to that nitrogen also. So here we go. We're going to try not to drop any hydrogens or carbons along the way. Typically, we might see this reaction done with some acid. We might have a catalytic amount of acid in there, or you might heat this up to drive off water. There's a couple different conditions that we can do to have this reaction go. So a couple different options. But okay, so we got this after the first one there. Now what we have here, right? We've got another amine, right, with an oxygen, right? So we're just going to bring those two together there. So let me change colors. So this is what we had before, right? And then we're going to take that and oops, sorry, got a little bit. Okay, so we're just going to take that and swap it in place there for the ketone oxygen there. And so we're just doing a double shift base here. kicking off some hydrogens along the way, removing water, that kind of stuff. So a good way to tether some different molecules together there. All right, this one we covered in class, that's why it's already written down on here. But I asked you guys to show me the tautomerization under basic conditions. So I'll just kind of pause here and, let you guys take a look at that mechanism there. This is going to be extremely important, especially as we get into chapter 22. We're going to talk a lot about, how acidic that alpha hydrogen is. And what I mean is this, right? This hydrogen right here is relatively acidic as compared to, just a standard alkyl hydrogen. And so it's important to kind of recognize that we can pluck that hydrogen off there with a strong enough base under the right conditions, and we can, form a tautomer of our aldehyde or ketone. But anyway, so that's all I really wanted to say about quiz 8. Just a couple, lots of important reactions in chapter 18. The Vidiq, very important. How to make aldehydes and ketones and reducing agents, all this kind of stuff. So make sure you're reviewing the appropriate reactions from each chapter, and I'll see you in the next video.